Have you ever thought about an AI that could do more than just, I don't know, label a cat in a picture? What if it could actually look at an image, get the whole context, and then have a real, back-and-forth conversation with you about it? Well, that's exactly what we're diving into today with LLaVA. It's the AI that's making this whole idea a reality.
So here's what we've got on tap. First, we'll look at the big problem LLaVA was built to solve. Then we'll get into its super smart, simple design. After that, we'll see how it got even better, explore this bigger quest to find the perfect AI parts, and finally, we'll check out the secret sauce tech that makes all of this lightning-fast innovation even possible.
All right, so let's get right into it. The first really big challenge for AI, has always been this huge gap between just seeing a bunch of pixels and actually understanding language. I mean, how on earth do you teach a machine to connect what it sees with what it can say? It's a tough one.
So, picture this. You pull out your phone, show it a picture from your last trip, and just ask it, hey, what's a cool fact about the architecture of that building right there on the left? That's the kind of thing we're talking about here. We're moving way beyond simple object recognition and into this world of rich, interactive understanding.
And this is exactly where LLaVA comes into play. LLaVA stands for Large Language and Vision Assistant, and it is a total game changer. It's this landmark model that just brilliantly connects those two worlds, vision and language. But here's the really crucial part. It's open source. And because of that, it's acted like a massive launch pad, just supercharging research and development for pretty much everyone in the AI community.
Okay, so what's really fascinating here is how LLaVA actually pulls this off. You might think it's some gigantic, brand new model they built from scratch, right? But nope. Its real genius is in its simplicity and its modular design. It's all about cleverly putting together powerful tools that were already out there. So, first up, let's talk about the eyes of the operation. LLaVA uses a piece of a model called CLIP, which is already a rock star at connecting images with text. And here's the key thing. This part is kept frozen. They literally don't touch it, they don't retrain it. It's like being handed a fully formed visual system that already knows what the world looks like. This gives LLaVA this incredible built-in understanding of images without having to spend a dime on training it.
All right, next we have the brain. This is where all the thinking and the talking happens. For this, LLaVA uses Vicuna, which is a really popular large language model. It's the part that handles your questions, figures out what you mean, and then generates those smooth, smart answers. This is really where LLaVA gets its conversational superpowers.
So, okay, we've got the eyes and we've got the brain, but how in the world do they actually talk to each other? Well, that is the job of this brilliant little piece of the puzzle, the bridge. It's a small, simple module that basically acts as a translator. It takes all that visual info from the eyes and converts it into a language that the brain can actually understand. And believe it or not, this tiny, trainable piece is pretty much the secret to the whole setup. And this whole design just screams efficiency. The training process is basically a two-step dance. In step 1, which takes only about 6 hours, they train just the bridge. They're teaching it how to be a really good translator while the eyes and the brain are completely frozen, not changing at all. Then, for step 2, they fine-tune the bridge and the brain together, using conversational data to teach it how to be a useful assistant. And the whole thing is just ridiculously resource efficient.
So LLaVA was already really good, right? But then came LLaVA 1.5, and it just blew everything out of the water, hitting state-of-the-art results. And the key to this huge jump in performance, it wasn't some massive change to the architecture. No, it was something way smarter. It was all about giving it a better diet of data.
What the researchers did was so clever. They basically created this custom data mix. They threw in academic Q&A data to make it better at giving you short, factual answers. They added a bunch of images with text in them so it could actually learn to read signs and labels. They even included text-only instructions just to beef up the core reasoning of the language model itself. This carefully curated mix of data turned out to be just as important as the model's design.
And, I mean, the results really do speak for themselves. If you look at the GQA benchmark, which is a major test for this kind of visual reasoning, LLaVA 1.5 is scoring over 63. Now, compare that to a similar model from before, Blip2, which was stuck down at 41. That's not just a small improvement, that is a massive, massive leap in performance. It just proved that their new training strategy was a home run.
So this whole modular design got the entire research community thinking. It sparked this really brilliant idea. Hey, if we can build a fantastic model by just plugging together an eye and a brain, what happens if we start swapping out the parts? What if we could try different eyes and different brains to find the absolute best combination? And that is exactly the quest behind projects like LLaVA-1.5.
So researchers started running these really systematic experiments. For the eyes, for example, they took the original clip encoder and put it head-to-head against newer options like SIGLIP. The key was they kept everything else the same training process, the same data, to get a really clean comparison and see which one truly performed better. And you know what? The results were crystal clear. The research paper basically says it all. SIGLIP consistently came out on top, it just performed better. And this kind of disciplined, comparative research, this is how the entire field makes progress. It's how we find better and better parts to build even more amazing systems.
But this research also turned up another really fascinating finding, something that kind of goes against the grain. Bigger isn't always better. The study actually found that some newer, smaller, but really cleverly designed language models like 5.4 could perform just as well as older, medium-sized models. It's a huge deal. It shows that smart design and high-quality data can be every bit as important as just raw size.
Okay, so this brings up a really practical question. How on earth are researchers able to run all these experiments? I mean, swapping out these gigantic AI models sounds incredibly expensive and time-consuming, right? Well, the answer lies in some new, unbelievably efficient ways of fine-tuning them.
I mean, just think about it for a second. To fully retrain one of these massive language models can take months and cost an absolute fortune. If you had to do that for every single little experiment, well, progress would just grind to a dead stop. There absolutely had to be a better way.
And of course, there is. The solution comes in the form of techniques like LoRa and QLoRa. Here's the brilliant idea. Instead of retraining all billion-plus parameters in a model, LoRa freezes the main model and just trains a handful of tiny new parameters. And then QLoRa goes a step further. It first squishes the model down to save memory and then applies LoRa. These methods absolutely slash the time and the cost of fine-tuning, and they become the engine that's powering all of this rapid innovation in AI.
So let's wrap this all up. LLaVA's genius wasn't about brute force. It was about a simple, smart modular design. The reason it became state-of-the-art? A better data diet. This whole plug-and-play idea has opened up a whole new world of research, letting scientists mix and match to find the best parts. And what makes it all possible? These hyper-efficient tuning methods that are the engine behind this incredible pace of innovation. And all of this leaves us with a pretty fascinating final thought. We've basically created a Lego set for building AIs that can see and talk. And now that we can snap these pieces together and test them out so efficiently, the bottleneck isn't really the engineering anymore. It's our own imagination. So the real question now is, what new, incredible, and amazing things should we teach them to see next?